So thanks very much for your time, Phil and Paul. I'm Mike Anthony from the University of Michigan. I have the pleasure of working with my colleague from our Fire Safety Department, Phillip Sabon, who is actually on the road right now. And then, of course, we have our colleague, Paul Dunphy, at Harvard University, who has APA's vote on the, or at least the education facilities industry vote, or Harvard's vote, on NFPA 3 and 4. And because in the interest of time, I thought I'd let Paul talk as much as possible. Everybody always listens to me. So, Paul, if you're able to tell us what you do there, and then give us a bit update on 3 and 4. And if you like, I can go to these links here, which you sent me a week or two ago.
Okay.
Remember these links? So go ahead, Paul. It's your airplane.
Okay. So my job here at Harvard involves me working as a liaison to city officials in Boston and Cambridge. They would be electrical inspectors, building inspectors, and fire prevention folks from either fire department. Also, I'm with the engineering and utilities group. We, in the process of our job, have to review all drawings for capital projects. So I get in on the very beginning of projects, see what they're all about, and then I sometimes get involved in assisting with permitting, and then through the progress of a job, I'll be involved with walkthroughs, and then at the end I'll coordinate all the inspections with the fire officials especially. So in doing that here over the years, I find that we get a lot of individual inspections of individual systems, and officials really don't have enough time on their agendas to do the type of testing that we think we need to prove that a building works as it was designed. So I've been pushing this initiative of integrated testing in new and existing buildings for probably 8 or 9 years now, and we've had great success in selling the initiative around the campus to stakeholders. We're seems to be always in progress of planning some testing for a new project or an existing project. We've probably got about 25 buildings done with various results. And every time we do a test, something else crops up that'll help us in terms of lessons learned. So that's basically where we're at. Because I've been pushing this initiative here at Harvard, NFPA got wind of it and invited me to sit on the NFPA 3 commissioning committee, technical committee, and that was a learning experience for me. Getting consensus from all the interested parties was kind of an eye-opener.
Yeah, a lot of people don't, but you're lucky. NFPA probably does the best in the land in trying to get the balance of interest. I'll say that much for this. It's not like the others don't try, but there's some historical reasons why NFPA is able to do that. But go ahead.
Right. So the NFPA 3 group, the technical committee, about 33 people, really struggled with the document as it came out of the NFPA senior group. They wanted it to be a standard, which of course uses the word shall. A lot of people on the committee, basically half and half, did not want it to be a standard, so we settled for a recommended practice. That was issued as a recommended practice. The last chapter, I believe, was a chapter on integrated testing. So the Standards Council at NFPA thought that the last chapter, integrated testing, should stand alone, so they broke it out into a separate document, which we worked on for a couple of years. And that hit the street. 2015 is the publication date, but it actually hit the street mid-year 2014 as a standard for integrated fire protection and life safety system testing. So I call it an owner's document because the local jurisdictions haven't picked it up and made it something that has to be done. So as an owner's document, we've been able to use it here at Harvard. Years ago, I put like a one-page list of expectations for integrated testing, and now I've got a book that I can refer to that's really helpful. And we're about to put words in our big capital project documents that will require integrated testing on all large capital projects.
Well, now that's normally handled in a commissioning. Remember, you and I had talked a bit about that a year or so ago about how do we cover those costs. Everybody knows that these systems, especially the life safety systems, are extremely complicated, and the smoke controls and the HVAC controls can easily fall out of calibration, so to say. How are you paying for these? First cost, I understand, as part of commissioning. Do you identify integrated fire systems as part of the commissioning budget, usually 0.5% of a new building?
It usually comes in under the commissioning portion, although I really don't like to see a commissioning agent also do the integrated testing. I feel like he's checking his own work, but
yeah.
In some jobs we've been able to afford to have a third party do that type of integrated testing portion, but a lot of it has been done by commissioning agents. We struggled at first and with trying to help them to understand exactly what we wanted, because typically commissioning companies don't get involved with elevators or generators or
right.
fire alarm systems. Mm-hmm. They usually back away from the table when you mention those things, and that's the problem. Mm-hmm. A lot of these companies are into energy efficiency and comfort controls, and not so much the integration of the systems, mm-hmm. the life safety systems.
We know that a lot of systems, a lot of buildings will have a 1-year or 2-year, let's say, guarantee period by the contractor. It depends on the project, of course, but it strikes me that one of the ways for paying for integrated testing under NFPA 4 would be to say that what do our fire, after we've had substantial occupancy for 12 months or very near the end of the warranty period, what do the systems look like? Are they still in calibration, so to say? That would be part of a first cost.
That would be great if we could get that. It's not easy to do integrated testing the way we do it here on the campus, because we completely shut down a building and pump smoke into it from the transformer vault. That's easy to do at the beginning of a project before we actually occupy. But don't get me wrong, we have gone into buildings, quite a few buildings after one building we did after 10 years had never had this type of testing done. It took us a year to plan it, but we did plan it and we did do it, and we learned a lot from that. The cost, if you buy it out early on a project, the costs are minimal. We've paid as little as $65,000 for a $350 million building project, and that was spec'd out real early. Everyone bought into it, and with good planning, we kept the costs down, mm-hmm. And we were quite successful in pulling it off when we needed to.
What building was that, just for chance? I know some of the buildings.
That was actually the 32 Quincy Street Museum, which is the Harvard Art Museum.
Mm-hmm. While Paul is... go ahead, Paul.
So the companies that are looking to get into this business of varied types of companies. We've seen, some of the big engineering companies take on the integrated testing piece around the campus, and we've seen smaller individuals be successful at it here, and we've also had real estate management companies take it on as a new initiative or a new business line, and we've taken it on ourselves with our own people.
So that leads into just a question I wanted, since we do have Phillip on the phone with us. Could you tell us if we are doing any of this at all as part of our fire safety program, Phil?
Am I on speaker now?
Yeah, you're on the speaker now, yep.
Okay. We commission, our department will commission a project, fire alarm system, and it's our responsibility to do it initially. But I am not aware of we are not doing, 10 years later, commissioning a system currently. But brand new, we currently do the full commissioning ourselves and grant our approval, and if there's any problems, communicate to the project manager to have it corrected through the vendor.
Is NFPA 3 and 4 your template? The design engineers may use NFPA 3, but now there's NFPA 4, and I don't know the degree to which, how much your office, when you have the power to grant occupancy, and that might be a little bit different with Harvard. Harvard, are you still using the City of Cambridge as your building authority having jurisdiction?
Yeah, it's inspectional services, which is the building department, has the final say. But the first AHJ group in is the fire department, and they'll basically test the fire alarm and sprinkler system. They don't get into the interaction between the fire alarm system and say a smoke control system or a generator system or security doors or things like that.
My own experience is that those air handling systems, and you get fairly complicated, actually gnarly systems in hospitals, for example, fall out of calibration very quickly. And so that's why I'm saying if you're going to fail, it's one of the classic models for failure. You fail early. It's almost like a bathtub curve. That's assuming, of course, it was correct to begin with. So all systems have to burn in, and when you're running a smoke control system, that strikes me as the more vulnerable of them. I think sprinkler technology is fairly well what I'll call finite, but the compartmentalization of air, stairwells, is a very difficult problem. So
right, and there's a lot of moving parts in those types of systems. Dampers have to be positioned properly and checked to see that they're actually in their proper position. So when we do this type of testing, we use some smoke just to get a sense of where it's going, but we also assign people to the various locations where we might see a fan start, a fan stop, or dampers open, or dampers close. We want to get a visual that it's actually in its proper, landed in its proper position. So there's a lot of adjustments, mechanical and electronic, in these systems that can fail or can fail over time. Of course, we're required to do annual fire alarm testing and elevator testing in the Commonwealth of Mass, but that's about it. We're not required to do the testing that I'm talking about, so this kind of falls off the table unless you embrace it. So I've been fortunate enough here at Harvard to get a lot of support in doing this.
We have a risk management department here. I don't know if you're thinking the way I am, Phil, is that while the construction contracts themselves typically don't permit us to finance what I'll call retro commissioning, that risk management has an interest here, and I don't want that takes a discussion in another area. But how do you pay for all this stuff, especially in these very complicated fire protection regimes that our newer buildings have? Paul,
Yeah.
I mean,
Hey, Mike.
Yes, sir. Phil.
We can talk after, but this topic is real interesting to me in regarding building a program on our campus, and we certainly could build the program and enforce it for future review of commissioning of these systems. And I know risk management would be on board, so we could get that backing, FM Global's backing. It would just be the financial piece on how to plug it in. And we actually have the people on staff, the fire alarm shop guys, to do the commissioning with our oversight. So let's talk, set up a meeting, you and I will talk about if we want to move forward at the university level of doing this.
Okay. Well, we have our inspiration at Harvard, and Paul's been done yeoman's service for us. We do have a time constraint here. I try to promise our listeners 30 minutes. And if you saw on the draft agenda I had here, I stated that we would give Paul the floor first, but I wanted to bring you up to date on some of the other action that's occurred. And we do need to focus a bit on NFPA 10, which is one of our focus items. That's the Class D material, management, fire protection that we had started last year. And if you don't mind, I'm just going to rip through the agenda and land ourselves right back on the NFPA 10, and maybe Paul has some insights into what they do there. And Phil, you can bring Paul up to date on what got us started thinking why we would give Class D material fire protection and testing and inspection a priority. So with that, I'm going to take us and bring you up to date that we are upon another revision cycle for NFPA 101. Josh Evolve, who actually has a vote for SFPA on that committee, he's not able to call in. He says his regards from, I believe, Mexico. So we were on the horn yesterday talking about that. So he'll make it at the next meeting, and he's an important person. He's the president, or at least the former president of the Society of Fire Protection Engineers. So just be aware that we normally have a number of rolling, continuous concerns that we put into NFPA 101. That's not my area of expertise, actually, but a lot of my friends are. So I'm just letting you know we have about 6 months to prepare new ideas for the next revision of the Life Safety Code. On NFPA 350, this is a new confined space standard, and Ted Widener from Purdue and I prepared about 10 proposals. It looks like 5 of those proposals were conceptually cleared and will appear in the document itself. So this would be the first NFPA standard on confined spaces developed by the private sector rather than by government agencies. So finally, that takes us to that takes us to NFPA 10 now, and we don't have Craig, we don't have our colleague from the University of Illinois on here right now, but I want to take us back, Phil, to Dwayne Lee and the teleconference we had in your offices about a year ago, and we were concerned about over-testing small quantities. And because this is not in my area of expertise, I'm hoping you're going to fill in here. But what you can't see was that we felt it was the thinking down in your offices that there could be a little bit more flexibility in how much Class D material, if we could calibrate or scale the Class D fire protection extinguishers with the size of the material, that could help us economically and maybe spread some of our risk around. It rose to the top of our agenda for another reason also, and it was inspired by this particular tragedy at UCLA, where a laboratory worker was killed in a lab, and I believe it was with Class D material. And UCLA, I guess they call it landmark worker death case because the professor is liable and was being tried for murder. And so this was, I'm sure this is, it's certainly not willful, and I don't want to get into legalities of it, but it gets kind of emotional when you have laboratory workers, you have tragedies of this nature, and then of course the complicating factor of the university. I'll just say they were ambivalent about whether they would support him. So I'm sure this is a whole spaghetti bowl of issues, and I really don't want to get into that. I want to get right back to the ideas right here. Phil, since you're in the car, you can't see what we have here, but this was put there in front of, excuse me, I'm going to show you the proposal that was put out there in front by Craig Grant at the University of Illinois, and I'll just call it up here if I can get that file to come up. And here's the proposal. So it says that the criteria for determining the threshold where Class D fire extinguishers are required shall be determined on the basis of a risk assessment approved by the authority having jurisdiction. And then we add an annex item. Among the criteria for this determination shall be the quantity of Class D material, its method of handling, and whether the premises is sprinklered. And you pretty much have got me to the limit of my knowledge on Class D fires and how you manage them. So Phil, are you able to speak a little bit to what the thinking was on how we felt there was a more scalable way to deal with Class D fires?
I think what our thought process was is that based on the quantity in that lab, you got a certain size of fire extinguisher. Based on that quantity, is that fire extinguisher actually going to suppress or knock down that fire? So therefore, if it is not based on the quantity, is the Class D really needed? That's what I'm trying to recall. I wasn't originally at the first one of Dwayne's submittal, what he communicated to you as a group, Mike. Is that correct?
That's coming from somebody who does it every day. So I appreciate that, Phil. So Paul, could you tell us a little bit how Harvard manages this?
I have no idea. This is not in my area of expertise at all.
Okay.
This would be over to our EH&S group.
Okay. Well, all right. So I'll add a little bit more color to it. What we were finding is that the laboratories, the instructional laboratory, we had quite a range of occupancies, and we would have, for example, in our industry, we'd have high school laboratories that would use small amounts of sodium, for example, and that some of the equipment in those classrooms was too large for the students to use, and that would propagate a secondary fire, which is worse. So we know that there's a number of different technologies for putting out a Class D fire, but the present language here, we felt that we wanted more granularity or scalability. So we were saying with this additional language that there were site-specific considerations that ranged from small laboratory, high school chemistry laboratory usage, all the way up to industrial usage, which we see often in our research labs. And I believe that was the case. That might have been the case at UCLA. I think it involved a code, if I'm not mistaken. But again, I need to stay away from that one. But that was our thinking, and that's what inspired this particular proposal. I believe I put this in on behalf of our colleague Craig at the University of Illinois. So what we're saying here is in some laboratory environments, combustible materials are used in very small quantities. Class D fire extinguishers are relatively costly to buy and maintain. So where the quantity is very small and the premises where the material is being used is protected with sprinklers or other apparatus that isolates the fire risk, a Class D fire extinguisher in an isolated location may not reduce overall risk as much as having portable extinguishers for other fires in other locations where the facility may not be sprinklered. So what we're asking for scale, balance, and cost rationalization are essential components of an effective fire safety program in light of the fact that it's financially impossible to conform to codes and standards that govern all safety risks. So we felt that a risk assessment, letting an authority having jurisdiction get in there and just look at what's common sense, that would be a criteria for determining whether or not the size of fire extinguishers, where they had to be, where they had to be located, and how often we had to test them. We felt that, and I believe there are types of technologies where you use sand. Is that right, Phil? Aren't there technologies there where, for small quantities, you can use an extinguishing agent that's like a powder?
Yes, that's correct.
Yeah. Okay. So we felt that determination ought to be done locally. And that was so. This is Craig's markup here. And that
when you read Craig's remarks on that, that sounded good. I would accept that. The only thing you might need to be added in there, some type of caveat that in the event that the product changes, it just flags that a review or consult is done by authority having jurisdiction. Trigger somebody in that lab to, hey, we got to get this reviewed.
That's right. That's right. So, and of course, speaking on behalf of my boss, who has, maybe we have 20% of the money we need to test all of our life safety systems. What can we put in that it doesn't require testing? And I'm assuming that the sand technology doesn't require testing. Is that right?
No, I think, yeah, you're correct. That wouldn't need testing because all the other products are actually in a device that's going to project it. So you have to, one, check how is it going to project it out. So that's got to be checked out.
Mm-hmm. Yeah, okay. Well, all right, so in the interest of time here, I wanted to just follow up on that. This particular proposal is due on January 15th. I wanted to get it vetted. I don't think it is that disruptive. It's informed by some of the material you'll see here from FM Global, but as always, you want to be able to determine leading practice that makes sense for your industry, and to have general industry acceptance as the standard of care. And I didn't want to not have this call knowing that we had done our due diligence to establish what a standard of care may be. We still have until January, and I will probably post these proposals, but these have been here for the better part of a year now, and we feel that we're on solid ground here unless we're told otherwise. So very often we know that many authorities having jurisdiction are a little bit skittish about letting. They want to see bright line standards. They want to see bright line standards, something that's easily to enforce. They don't want. They don't want to be in charge of having to make the interpretation of what the appropriate extinguishing method is. So, and of course, there's many different types of Class D materials, as I understand it. Sodium being the one I'm most familiar with, but I believe there's magnesium, which is even more lethal. So, anyway, so I guess I would consider this particular idea fairly well vetted. If anybody listening to this call would like to talk more about it, my hope is that I'll have a Craig Grant will submit this on his own because he is a fire professional. I'm pretty good at understanding the process and the deadlines, but the nuances, the fine points of understanding, they don't come naturally to me as they would, say, a fire protection engineer. So with that, I think we're coming on our time limit. And the only last thing I wanted to say is that there is a document for premises security that NFPA has produced, and its proposals are due. This is Chapter 11 in this particular document deals with the safety and security of campuses, educational institutions. And so really I'd like to get some, I really should be moving post-haste on this, but we have had some success making changes to this document. This is the only, what I'll call premises security document that's developed by a nonprofit that is a non-governmental agency. So in that sense, we're glad we have a platform for all the material affected stakeholders to get their ideas vetted and agreed upon. So that's kind of it, guys. That's it. I think it's a wrap.
All right, Mike.
Any other questions or any other comments? I'll post this. I'll post this in a couple hours or so. And grateful for your time. Let me know if I can help you out there, Paul. And
okay.
You and I will talk a little bit later. So stay safe there up on US 23. I know it's going to get the snow ought to be blowing over there pretty soon. And
yeah, it's bad. I'm going about 30 miles an hour now. So.
And as you can see here, Boston University still looks very nice. So.
It does. So far, so good.
So be careful. You know
it's not even Thanksgiving yet. Let's keep the snow out of here for now.
Well, I was actually there's another webcam that I have over at Michigan Tech. Michigan Tech is in our Upper Peninsula, and it's really that's a place where they'll typically have 8 feet of snow. And just for amusement here, it might be interesting to see what's going on up there. Phil, you wouldn't be able to see this, but let's see what the students are marching around in. Look at that.
Look at that, huh? Yikes.
That's just the change of classes over there. So, okay, gentlemen, thanks very much for your time.
Okay, take care.
Bye.
Goodbye.